So today we're going to be doing Astronomy and Cosmology. Hi, my name is Bilal. I'm an ex-A-level student, and today we're going to be doing the new chapter added to the Physics 9702 A-level syllabus. It's a very simple yet very interesting chapter. So without further ado, let's do this. So the first question that should come to your mind is, what is astronomy? What is a solar system? So very basic definition of astronomy would be, it's the study of the solar system. And what is a solar system? A solar system is a collection of planets, moons, asteroids, comets, and other rocky objects traveling around the sun. So any system is a collection of stuff, and the word solar refers to the sun. So a system around the sun. Now let's move on to the A-level stuff, the stuff in our syllabus. So let's start off with the basics. If you're an A-level student, you should know and probably would know what intensity and power are. So intense power and intensity, and you should know what equation links both of them. That equation is intensity equals power over area, right? Now if I replace these names with symbols, I'll write I is equals to P over A, right? Forgive me for my horrible writing. I is equals to P over A, right? I can also write this as I is equals to P over 4 pi r square, right? 4 pi r square being the area of a sphere, because this is area. So I basically replaced A with the area of a sphere if we're looking at the area of a sphere, right? So that's very basic. Now let's move on to the stars now. So I told you about power and intensity because they are very closely linked with what we're going to study now. So I'll write down a subheading, and the subheading is luminosity and radiant flux. Now these names may seem intimidating at first, but don't be scared of them. They're actually very simple stuff. So radiant flux intensity. Now let's talk about luminosity first. So I'll write down a subheading. So I'll write down luminosity. Now what is luminosity? So luminosity is basically power. It's another word for power, but we use luminosity when we're talking about stars specifically. So you can't go to other chapters and use luminosity as another term for power. But when you come to the chapter Astronomy and Cosmology, whenever you refer to power, you'll say luminosity. Hence, we can give luminosity a simple definition. We can write luminosity is the total power of radiation emitted by a star, right? So luminosity is basically power, but when we're talking specifically about stars, we use the word luminosity. So we know the formula for power goes like power is equals to energy upon time. Hence, luminosity will have the same formula because luminosity is basically power. So luminosity is equals to energy upon time, right? Now, at the start of every question in the exam paper, there's a 1, 2 or 3 mark question where they ask us to define stuff, and they might ask define luminosity, and this definition I wrote is a full mark scoring definition. Or if you want to link closely to the formula I wrote, you can also write luminosity is the energy of radiation emitted by a star per unit time. Per unit time is very important. Per unit time, because as we see in the formula, upon time means per unit time, right? Now that's luminosity. Now we'll talk about the second heading I wrote, radiant flux intensity. And please note the symbol for luminosity is L. Now we'll talk about radiant flux intensity. Radiant flux intensity. Like luminosity was linked to power, radiant flux intensity R is linked to intensity. So it's basically another term for intensity, but when talking about stars, we call or rephrase intensity as radiant flux intensity, so the person knows that we're talking specifically about stars, right? So as we saw, the form, actually I'll tell you a basic definition first. We can define it as intensity of radiation, and we're repeating the word radiation because a star basically has billions of chemical reactions going on, nuclear reactions going on, which causes it to emit energy. A good example would be the sun. The sun is a star and it emits radiation at a crazy rate, as thermal radiation due to the nuclear reactions going on. So radiant flux intensity and luminosity are basically measures to measure how much radiation the star is giving out, right? So the formula for intensity is intensity is equals to power upon area, right? Now we know that intensity can be written as radiant flux intensity. Power can be written as luminosity. Hence, we can replace these symbols with R is equals to L upon A, right? R being the radiant flux intensity, L being the luminosity, and A being the area. Now, what we'll do is we'll replace area with 4 pi d squared. Now you might say, man, you just said that area of a sphere would be 4 pi r square. Why are we writing 4 pi d squared? So the simple answer is that this formula is used specifically for astronomy and cosmology only. You cannot use this in any other chapter. And d does not stand for diameter, nor does it stand for radius. I'll just tell you what it stands for. So I'll tell you what everything in this formula stands for. R stands for radiant flux. I love the word flux. Flux intensity, right? And the units used will be watt per meter square, right? Because the units for intensity are watts per meter square. Hence, for radiant flux intensity, the units would be the same. And if the examiner gives you any other units, you have to convert it to watts per meter square to get the right answer, right? So L stands for luminosity. The units for this would be watt, because L is basically power, and D is distance to a galaxy Right. Now you might ask, distance to a galaxy from where? So it can be distance to a galaxy from wherever you're standing, from wherever the observation is taking place, right? So if I'm standing on the earth, if this is the earth, right? If this is the earth and I'm standing right on the surface of the earth, I'm standing right here, right? I'm standing right here, and what happens is that this formula is used when you observe a star, a specific star. We'll talk about what kind of star you observe in the future upcoming lectures, but what happens is you observe a star in a distant galaxy, and you you use the luminosity of the star and the radiant flux intensity of the star to find the distance to the galaxy, right? So what happens is, for example, this is a galaxy. It's a distant galaxy. Distant galaxy, right? And there's a star inside which has, I hope you can see it, I'll use a darker color. There's a star inside of known values of L. You know what the value of L luminosity for the star is, you know the R value for the star. Hence, they'll ask you to find the distance d, right? So this distance d is the distance from the earth to the distant galaxy, right? But you use a star for this, and this star will have known luminosity and known radiant flux intensity. And please note that this is just general knowledge, but it's good to know that radiant flux intensity can be found using a telescope or a device called a charge coupled device. A short form for this would be CCD, charge coupled device. This is not in the syllabus, but it's good to know, right? So I'll just write it in case you want to remember it. So R can be found by using a telescope or a CCD, short for charge couple device. Okay. So that's how you can find R. And if you're given and what the examiner will do in the exam is that he might give you the values for R and L, and he'll tell you to find the value for D. He'll tell you to find the distance to the galaxy, or he might give you the value for D and the value for R, and might tell you to find L, or he might give you the values for L and D and ask you to find R. So he can play with the variables, and you just need to remember this equation, because this equation is not given in the exam. So you have to memorize and remember this equation, and you need to memorize what units are used. So you'll always use SI units, and I forgot to mention that the units for D would be meters M, right? So that's all for the first lecture. I hope you understood the stuff I tried to teach. I hope it was helpful, and it would be good to recap what we did. So the first thing we did was luminosity. Luminosity is basically power, right? The second thing we did was radiant flux intensity. Radiant flux intensity is basically intensity. And the third thing we did was we found the distance to a galaxy. So these are the three things we did in today's lecture. and the formula you need to memorize is F is equals to L upon 4 pi d squared, F being the radiant flux intensity, L being the luminosity, and d being the distance to a galaxy, right? So that's all for the first lecture. I hope you understood this. I'd highly recommend you and suggest you and advise you to watch the upcoming following lectures so you can cover this topic fully. And at the end, we'll do some past paper questions as well. Let me know in the comments if you guys have any questions at all. This was our first lecture, and there'll probably be 2 or 3 more lectures to follow. It's all very basic yet very interesting stuff. I hope you guys learned something from this. I hope it was easy. Thank you for watching. Don't forget to like, subscribe, and please do share it with your friends, because they're probably having problem with this chapter too, and this might help them. So sharing is caring. Thank you.